Hello guys and welcome back. Well, not back. I always do that. Bad habit. Anyway, this is SpaceChem. I just got the demo. I'm waiting for the full game to go on sale. And this game, I've already sunk, I think, 3 hours into it. Oh my god. It is fantastic. It's a really nice puzzle game. Really gets your mind thinking. So, let's start off. We'll do the brief hold on, whoopsies. That's actually an external video on YouTube. Anyway, let's do of pancakes and spaceships. Yes, I'm not gonna go through the story, it's just too much reading. Okay, anyway. Let's input A. Well, hold on. So, I'm gonna go through all of this with the tutorial. This is an instruction which executes when the matched Waldo, which are these circle things, passes over it. The instruction accepts a molecule into the reactor. Over here is the molecule that is going to get inputted. These 16 squares are the same as these. So when this Waldo passes over an input A, well, I'm gonna say A just because it's easier to say than alpha, beta, and omega and everything. So these two oxygen atoms, which have a double bond, are going to be inserted here and here. So let's put an input A. Now this instruction causes the Waldo to attach to and release atoms. This will pick up the newly accepted molecule. So this instruction redirects the Waldo to move to a new direction. That's just down, left, right, and up, and then rotate, up, and I want to do drop. Well, if you right click on things, you can change their pretty much everything about them. To start the reactor, click any of the 4 play buttons at the bottom. So you see it grabbed it, it inputted, grabbed. Now the Waldo's over this oxygen. Now we'll rotate and go along the path, dropping it and then outputting it. This is slightly different. Okay, now if you press tab, you can switch between different colors. So input beta, up, right. I'm just doing what it says right now because I don't think you really have a choice. But then we're going to drop it here, down, and out. Yeah, shut up. In fact, I think I'm gonna do... Yes. I'm going to try to do this as quick as possible. That is the least number of moves. Going over this twice. Okay, I think that'll work. Grab. Drop. Grab. Drop. So that should give me a few less cycles. Same concept, just a bit easier. And if you don't know, each cycle is one movement of one Waldo, one space, or one rotation. Okay, so now you have the basic concepts, or at least I hope so. I've gotten quite good at this game. So, that's the basic loop for blue. And then red will have a very similar loop. This time, input, grab that, drop it, and output. See if this works. Okay, so basically what happened there is that two Waldos carrying, one carrying gold and one carrying platinum, if they collide, the reaction is no longer stable and it stops. So we can't have these things intersecting. Simple enough. We just do... not that. Sorry. Just do this and... that. That should fix it. In fact, we'll just do that for symmetry's sake. Now let's see if that works. They don't pass through each other, or at least they don't try to. Drop out and... See, what happened there is that these things are out of sync. They get out of sync quite quickly. If I go... you can see them slowly getting out of sync. One cycle every round. Until tragedy happens. So what we want to do is put a sync. And what a sync does is it will wait. Once a Waldo hits a sync, it will wait until the other Waldo hits a sync, until both of them go. So doing that will get us through. That was called crossover, now an introduction to bonding. I'll explain this. You can move these things and rotate them, whatever. Now, of course, input, grab, down, right, go to the blue, wrong one, input, up, grab, right. Now, these battery-looking things, sync it, as I said, and blue will drop its fluorine. Again, we're trying to make silver fluoride, which I have no idea what that does. Now we have a new instruction called bonding. Now we can just finish off the blue loop, go up, right, sorry, left, and output. Let's watch this thing. So it grabs the gold and fluorine, waits for the sync, bonds it, and now there's a single bond between them. Drops it and outputs. And it keeps on doing that. Brief history of SpaceChem. Now, of course, I believe it's the first high school class of science that teaches you all about how many bonds everything can have, and the difference between ionic and covalent bonds, but that doesn't really apply here, it's just bonds. It's all one thing. Okay, now we need hydrochloric acid out of hydrogen and chlorine. Should be quite easy. I've done a lot of these in my day. Now we need to grab and drop there. Where's this? In fact, grab that, drop that. You can grab that. And let's go over here. Bond it. Now we have the hydrochloric acid, and we need to output it over here in the I think that's omega. I'm not sure. I don't know my letterings. Hopefully that works. Actually, we might want to sink. If you don't know where to put a sink, just put a sink like right behind your start or right in front of it. Okay, so that worked. I don't even need a sink actually, so might as well get rid of those to save a few symbols down here. And that's basically your high score, is your cycles, symbols, and reactors, which reactors we'll get to a bit later. Again, this just shows you like a heat map of how many people got a certain amount of elapsed cycles. Now, removing bonds. This is basically the same thing. Input. Now, since it's going to be inputting fluorine, right here, we can grab this fluorine, do a bond minus in between these, and that should keep hold of one of the fluoride atoms. Drop it there and sink. So we wait for that to sink, and then we actually need blue to grab the other fluorine. Well, we could do red, but we might as well introduce blue. Now we need to drop it there, come down, wait for the sink, and output. Actually, we want to output this as soon as possible. I'll just see how this works. Probably not that well. Oh, I accidentally put 2 sinks in blue. My bad. Okay. Hopefully this works. Drop out. Looks like it. Okay. Probably not the most efficient way, but it's a way. Actually, that was decent in symbols and cycles. Now we unlocked a new planet and double bonds, which are just bonds but double, if you didn't realize that. Now you don't need 2 bonders here. You only really need 1. Grab. This is what you do. Of course, input, grab, drop, and then using the grab icon again, you can go over it again as long as it's at a different angle. Drop it here and click bond twice. Go back and let blue pick it up. Wait for the sink. Let's see, we will need a grab here and drop, and of course our output. Let's see if this thing works. Grabs the oxygen, drops it, drops the other one, makes a double bond, blue grabs, drops it, and outputs. Oh, that was pretty bad, that was pretty inefficient, but don't really care. On the later levels, it's an achievement just to beat it. Yes, I'm not gonna go through the story. And more bond progression. Okay, now we need 3 bonds. This one is not really tougher at all. It's just the same thing. Need to do this, that. Put the start over. Grab drop, and bond, bond, bond. Well, you can put that there, and grab that, drop it, and of course, output, as always. That should work. Forgot to do a red sync. Let's see, where would the sync go? There. Sounds good. Forgot to input up here. That would probably help. We have 3 bonds in between the nitrogen. And there we go. That's it, really. I could spend time making each of these more efficient and with less symbols and everything, but don't really feel like it. Carbon monoxide into carbon and oxygen. Now this is a double bond, so we have to remove 2 bonds. And grab that. Drop it there. Minus. I accidentally deleted it. Minus. Okay, and then this, again, we can... Well, not again. I always say that. I always say again. I'm bad at commentary if you haven't noticed. Now, this will be the oxygen molecule, so we want to drop that and output. Whereas blue will wait for a sync. That's fine. Actually, I think that will be fine. And grab that, drop that, put, and output. Let's see this thing in action. Removes the bonds, and works out quite well. Now the demo only has 3 planets, whereas the full version has 1, 2, 3, 4, 5, 6, 7, 8, 9 planets. I've completed the first 3, I think. Yeah. On my other laptop. Now we get introduced to reactors. Well, not really, but the main screen, sort of. I don't know how to describe it. Basically, you're gonna have to be working with pipelines as well. Which, that's just simple. Benzene, that's annoying. And acetonitride. Not sure if I'm pronouncing that right. Both of these very complex, but it's just an introduction to pipelines, as the title suggests. And of course we need 40 molecules this time. 407 elapsed cycles, that's really the least you can do. Something in the fish cake. Okay, now we can do reactors. Which each reactor is this thing. Hydrogen goes in at the top, and chlorine at the bottom to make hydrochloric acid at the bottom output. Of course, on the left are inputs, on the right are outputs. Hydrogen and chlorine. Of course, it tells you what you have to create if it's a direct link to an input or output. If it's a link to another factory, however, it doesn't tell you what you have to create. Okay, so let's get started again. Grab. Now, it doesn't matter the exact direction of all the molecules as long as it's the same molecule. So, for example, I can drop this, and this can bond. We could put a sink here and here. Now, in the event of simultaneous orders, red takes first. So, like, if I had the sinks here, they would both go. Well, might as well show it. Input. Okay, so as these are synced, if they were synced, they would go each one cycle to the right, and red would try to bond first, but since blue hasn't yet dropped it, because red takes authority, I guess, red goes first, and so it will try to bond. However, there's nothing to bond, so red will go on and blue will just kind of stay there. In fact, I think that actually does show. If I have the sink there. Oh. It does. Never mind. Forget I said anything. Actually, I might want blue to bond instead of red, because it's going out to the W output. Now drop it there and output. It's waiting at the input just because it has to wait for the molecule to go through the pipeline. There we go, 653. Sleepless on Serminer 4. Hydrogen, oxygen, carbon. Ooh, this seems a bit more tough. Let's try. Now, I think the best way to do this is probably just going, hold on, I can make this thing a bit more condensed. I'm doing this wrong. Hold on, I got it. Okay, now the best way to do this is probably the double bond first between the carbon and oxygen, and then add the two hydrogen on afterwards. Now, I don't exactly know how to show. I've seen other people show the results when another reactor is the output, but you can click between reactors using this. So this is the oxygen and carbon input, whereas this is the hydrogen and carbon and oxygen. I have no idea what I'm saying anymore. I hope you guys do, because I have just no idea. Well, go blah blah blah. We want red to take responsibility for the bonding and drop it, output. See if this works. Oxygen, we need sinks. Where's sink? Oxygen? I'm retarded. Anyway, looking like it. Now this will get the oxygen with the carbon. In fact, which one is on the bottom? Okay, so carbon. So the output would be oxygen here and carbon here. So the input would be oxygen here, oxygen here, carbon here. Even though they would keep their bond, just they would remain the same place as wherever I left off this. Carbon and oxygen goes to hydrogen to make formaldehyde. Now, this is a bit more complicated. You want to kind of shape these things in the way of the thing you want. Grab, put the carbon here, drop. Now red has the job of getting 2 hydrogens, grabbing those, dropping them. We'll get that a sink, and then a double sink here and a sink here, and that will always work. You have a sink right ahead and right behind the blue, and a sink right two sinks behind the red. That will always work. That will pretty much never collide. Now drop that. Go through the input again. Drop. Now we want to go through a sink here to allow blue to drop that. Actually, we want to bond. And then after we bond, we should probably get rid of those and drop it off here. I think the faster method would be like that. Now output, there. See if that works. Of course, blue is going to have to wait a much longer time for its oxygen and carbon, because balls. How are we going to get around this problem? Quite simple. Drop. Let's see. So start input grab, it drops it here. Goes through the sink. Does input alpha here, drops down. What if I always get that wrong? Okay, that should work. At least I hope so. Maybe not. Because then I have to drop this here. Wait for a sink. Bond. Let's just see how that works out. I'm gonna probably need to adjust it later. Hydrogen drops and that drops. Bond. Okay, so that's quite simple. Now, after the bond, we just need to grab, go up. That should work. That should work. I don't understand why it wouldn't work. Go triple speed, bond. Oh, balls. I see, this needs to drop. Actually, grab drop would be more helpful. Bond twice. go back around, grab it, and then drop it. Okay, so that should work. Now it's double bonded. Wait for the hydrogen to come down. Sync, bond, drop. Oh, hold on. I think I have one too many syncs. Let's see. Yeah, I have one too many syncs on blue. Triple speed. This is very inefficient, just because the Waldos are pretty much always waiting for each other. I'm not going for efficiency, really? Oh god, that's awful. Not really awful, but pretty bad. Now we go into Danopath. This is where it gets hard. Okay. Quotas and output nodes. That's fine. This baby. Ooh. Okay. I'm going to need... A good question is whether to bond the carbon and hydrogen first, or whether to bond the two carbons and then attach hydrogens afterwards. In fact, I could just grab that. Input, grab, drop. Not grab, I need input beta. Drop. Bond that 3 times. And of course, wait for the syncs. Just gonna give myself a little extra room. Whereas red can wait for a sync. Input, grab. I don't need that extra bond. I always do that. Put that. Drop. We're going to need 2 syncs. Drop up over input, grab, drop, bond, grab, down over, drop, and output. I got it. Let's watch this baby. This is a monstrosity. Well, you haven't seen anything yet. Unless you actually have seen something. In which case... I don't know what to say to you. I really don't. Anyway, so... Carbon double bonds. Hydrogen. Now. There we go. Hydrogen, there we go. That's pretty good. Not great on cycles, but decent on symbols. It takes 3. Hydrogen, ammonia. Okay. Ammonia. Let's go start up, input, grab, down, you blammering fool, drop. This will wait for sync. Actually, I need it to go like that. Have an up on the blue layer. Red will input, grab, go down, over, drop, input, drop, and then finally blue syncs. No, blue actually needs to grab this third one. Needs to grab the third hydrogen, that is, because red can't grab anymore. Red is already maxed out. Grab that. That might pose a problem, but I can fix it. There we go. Drop. Now what? Ooh. Wasn't thinking. Drop. It's gonna grab this. Drop. I see, there is a point to grab. Drop, and now I just screwed myself because I can't reconnect to the start. See what this game is like, puzzly? As in, extremely annoying?